So, hey guys, what's up? This is me, San. I'm back with another video with linked list operations. Today, we're gonna see how the insertion in linked list has been done. In my previous video, I've shown you guys how to find the nth node that has been given by the user. You have to search that nth node in the linked list. So, I guess that has been a little bit hard for beginners to understand. So I promised you guys that I will be coming up with videos in the future with all the operations from basic of the linked list. So if you guys know a little bit of linked list, what is a linked list? It is a data structure, right? uh, where we can perform multiple operations. And if you guys want to know what is the difference, what is the main difference between an array and a linked list, is that the size of the array once mentioned or once defined cannot be changed. So it can only be changed in C, where we can use dynamic memory allocation, but in Java we cannot change it. So we use linked list, as linked list has its size dynamically, so we can basically add anytime data or remove it. So that's the main point advantage over arrays. So I'm not gonna focus on more about the theory portion right now. I'm just gonna focus about the coding portion, like insertion and deletion. And after I complete all these operations with upcoming future videos, I'll be posting or I'll be recording some of the theory portions too, so that you guys understand the theory also, because there are some theory concepts that you guys need to understand as a beginner or as an intermediate. So let's just not waste any more time and see today in today's video how insertion sorry how insertion is done first at the beginning and the end. So we will see these two operations first for today, that insertion at beginning and insertion at the end. Then we're gonna see another operation, another famous problem, to display the length of the list, right? So first we're gonna see how we can insert at the beginning, how we can insert at the end. Then we're gonna see how we can display the linked list, and then we're gonna see how we can count how many nodes are there in the linked list, and we can display that integer. Okay, so let's hop in. Let me start with this first one, how we can insert a node in a linked list at the beginning. Okay, so let's go. Let me delete this. Okay, I'll set this one. Okay, so suppose this is a given linked list, or suppose this is the initial linked list. So let's say we need to insert at the beginning, means we need to insert here, right? And this is the beginning pointer, right? The head pointer. Every time a new node is insert in every time the new nodes get inserted in the beginning becomes the head pointer, right? The head pointer points towards every new node. So the theory or the statement goes like this: the head pointer points to the every starting new node. Okay, guys, one thing more. Please bear with me the handwriting, because I've been notified by many of my viewers that my handwriting is not clear. But I'm trying. I'm trying in my videos. In the upcoming videos, I will try more to basically uh, improve my handwriting. So please bear with me. If you have any doubts, you can comment down below. And also, no, not forget to like and click on the bell icon, because that really helps me a lot. I mean, as this courses or this information is helping you a lot in your lifestyle, that little thing will also help me. So please cooperate with me, guys. And if you are new to the channel, please don't forget to hit the subscribe button. Every week there will be new videos on different data structures and also different programming fundamentals. Okay, so let's go and concentrate on the topic here. So where was I? Okay, so yeah, this is the exact statement that you have to keep in mind, because this is what is happening every time you're inserting a new node in the beginning, right? Easy. There's no doubt in the statement. The head pointer points to the every starting new node, right? Because at the moment of time a new node gets inserted, it is being inserted in the first position, right? So the head pointer always points to the first position, the initial position, of course, and the 1th index, right? So easy, not a problem for me. We can move ahead. Okay, so guys, please, you can take a screenshot or you can write this important, this is very important for you to understand. So you can write this piece of statement in your copy, or you can just take a screenshot or a picture, anything. So let me remove this. Okay, let me just remove this because I've been needing this diagram. Okay, so so easy. There's nothing more logic. We need to insert at the beginning. So if I basically concentrate on the particular function, the function goes like this. Okay, let's not okay. Let's not do this. Yeah. Let me make it easier for you, right? Yeah. So let me do it this one. Yeah. Okay. So the function goes like this. Push at big means inserting a node in the beginning. Pardon me for the exact function name thing, because I'm not being able to write the whole full form function name here. I'm just using short forms here, so please pardon me for that. I'll be telling you where I'm using a short form, and I'll be telling you what that short form exactly replicates to, so there's not a problem. So I'm not writing a clean code over here, but I'm just making you guys understand. So I'm not doing any competitive programming over here, or I'm not giving an interview. So I guess you understand this thing. Okay, so let me just take the data, or the data that the node will hold. That data should be passed as a parameter to this function, right? So I can do this, and now I can basically create a new node using this particular thing. So guys, I understand that this is just making a new node using the object by calling the object, or you can say not calling the object, sorry, my bad, by creating an object of the particular class, node class, that we have created above this specific function. Okay, so I'll be giving you, or I'll be showing you the full code, not to worry. Now just focus on the particular function and the functionality that the function is showing, or the function is displaying, or it is working with. Okay, so please don't go with all these objects and classes right now. I'll be explaining you guys all those things. For now, focus on the exact function. Okay, how it is happening. Okay, so let me create a new node. right? Using the object. Okay, this new node is using the object reference, and this new node, this is just an object reference. Okay, through this we create a new node. Okay, wherever we are gonna use the new nodes functionality, we're gonna use this reference. Okay, reference variable. Okay, so object reference, yeah, the exact term. And I can give it here the data, right? With which data the box is gonna make. Or you can simply think about this with, suppose you are in a cake shop and you are and the cake the shopkeeper asks you that with which flavor you want to have the cake displayed over you. So it can be either chocolate, or it can be either strawberry or pineapple, anything, right? So like that. So this function is asking for you the parameter. This public void push beg is asking the public void push beg is just nothing but the shopkeeper, you can think like that, and it is asking for us the flavor, in the sense the data. So I'm providing the flavor in by creating the object. So this object reference, this new node, will consist of the data that I pass over here. So that is clear. So guys, if you have any problem about the object creation, function calling and all those things, how can you make a basically call a function in a in main, in basically driver code, that is main function, you can call other functions using the object that you make of the class. So if you have any problem on that, I'll be making an object oriented programming language course very soon with Java, where I'll be making you understand all the OOPS concept, all the OOPS pillars, and also how objects and class works in the Java program. How what are objects and class, what are the functionalities of it, what are the advantages of using an OOP language. So I'll be doing that. Okay, give me some time, I'm promising I'll be doing that. So for now, let us not dwell ourselves into all those things, but let us concentrate on the functionality. Okay, for the beginners, please bear with me. If you don't know anything about OOP or anything about Java and you want to learn, so probably this video is not for you guys, but I can promise you that I'll be bringing more videos where I will be starting from basic Java, okay, code Java, where I'll be making you understand all the OOPS concept and classes and objects and all various functionalities over that. Okay, so not a problem. So our new node has been created successfully with this simple line statement. Okay, so now what we're gonna do is we're gonna set this new node's next pointer to the head. So now, what is the meaning of this? Anyone, what is the meaning of this? Everything is going out of your mind, like what's happening, what's Shantan is making us understand, I mean, like, what is going on, man? Okay, so this has been done, right? So what is happening here is, suppose this is the first node, right? Node number 1, this is the next. Okay, this is nothing but the next pointer. Okay, you don't understand, I understand. Let's go and let's remove this, and this is the next pointer, right? PTR, and this is the data part. Now you all know that a node's next pointer, keep this in mind, a node's next pointer points to the next node data, right? So this is pointing towards this one, this is the data 2, right? So this is pointing this one, and this will point to this one, and this one again, this one will point to this one. So it will go on, it will go on. This is how the linked list is working, right? This is, keep this in mind, this is single linked list, not talking about double or circular or something like that. Okay, So this is the whole architecture, the structure of the linked list, right? Single linked list. So this is how it goes on. So here what we are doing is, if you just think for a bit using your common sense, whenever we are inserting a new node, suppose this node is going to insert over here, right? This node number is 2. Suppose we have this next nxt. Now if you want to insert this node over here, then this next pointer will be pointing towards the current head pointer, because this node previously, before adding number 2, this was 1th node, and this 1th node was nothing but the head pointer. The head pointer was at the beginning. The head pointer was lying at the first node, like 1th node, right? So what I'm gonna do is, I'm gonna, before, like how to basically add, you just cannot take the node and push it through. Okay, that's not gonna work. You have to understand, that is the logic, that is the business logic that is happening, that is the common sense. So the new node's next pointer, if I point it or if I connect it to the head pointer, I mean this one, if I connect it to this one, then this particular node becomes the first, partially, for 50%. Problem? You cannot understand? Okay, let us understand again. Yeah? I clear this up. Okay. So suppose there is only one node, right? This is the data, and this is the next, right? Now I'm gonna insert, this is the, okay, this node is mentioned as number 1. I want to insert another node, that's number 2, over here, right? Now the head pointer is pointing towards the first node, that is the 1th node, right? Now as we know, in a linked list node, this part is nxt, next, this is data, dt, right? If I point this next pointer with the head, that means nothing but, if I point this next pointer to the previous node or already consisting node can be also referred as the head. Yes, because it's a first node and we are inserting on the first. So if you want to insert at the first, then the previous node becomes initially the first node that was already in the first position. That can also be referred as the head. So if we point the next pointer of the new node with the head, this becomes 50% first node, because the work isn't done yet. We need to do another things too. Okay, and as soon as we do this will become now this thing. Okay, this has been inserted, node number 2 linked, as we have done this thing, the new node at next. I have been pointing the next to the head, that means the initial one, this is number 1, this is the data, this is the head portion, head head portion, and this is done. So now head is pointing towards the second node. Is this applicable? Is this an applicable rule for the linked list? Is this the applicable rule for the linked list? No, because the head always points to the first node. So what we're gonna do, we're gonna push this head pointer here, push head to the first, right? This one, we are making the head as the new node. So now head will point, now head points to 2th node. That means node number 2, which is present in the first. So this goes on. How many times you push a new data, a new node? This head will push from the second to first, then again another node will insert, then again it will push to first. Every time a new node gets inserted at the beginning, the head will be pointing towards that first node by pushing itself. So it will not push itself, you have to push it using the code statement. So I guess this is clear, easy, nothing to get worried about, nothing so complex, nothing. We are just using 2 lines to basically insert a new node. What we are doing, interchanging the position of the head, and we are linking the new nodes next to the previous starting node, so that the previous starting node becomes the second node and the new node becomes the first node. How we are understanding the new node is become the first node? This line. As head, we are making the head pointing towards the new node, and we know by the rules of the linked list that head only points towards or to the first starting node. So we are basically editing the rules, making the rules, and going by the rules. So it's just we are making the exact structure or the exact program understand, or the machine or the compiler understand that, see, this is linked lists rules, and I'm not just doing anything, I'm just making a new data or making a node with the data that has been given by the user, and I'm just editing some of the rules by not violating some points, nothing else, right? So easy, easy, no problem, no problem. 2 lines of code. Now we have understood how we can do this in the beginning. Now let us concentrate how we can basically add it at the end. Now people asking me that, okay Shantan, you've done it at the beginning, then how can you do it in the end, like serious data? So let us see how we can basically make this thing at the end. So first let me basically draw the structure for the problem statement. Okay guys, I guess you have understood this first problem. If not, then you can always comment down below, I'll be reaching it out to you. Okay, so this one is, suppose there are, okay guys, I'm not drawing again the next pointer or the head pointer, I'm just drawing the head one. I guess you've understood the structure of a linked list, single linked list, and we need to insert, this is null. Okay guys, always remember, last dot next equal to null. This means the last node of any linked list always points to null. This is another rule, okay, never forget this. As because I'm not doing any theory portion, so I might not be covering all the theoretical aspects, but please remember this is very important point, that last, if this is the last node, then this is the nxt one, and this nxt points to null, right? So how to understand that that is the end of the node? See, everything has been provided you in the rule book, everything has been provided, just a common sense, man. So we need to see. So okay, now if I contemplate the compiler as a machine, not a machine, uh, platform, or just a person, and if I say that person that find the last node of any linked list and insert a new node at the last, so how that person will understand that it is the last node? When while traversing the list, when that person finds the node's next pointer is pointing towards null, that means we have reached to the end, right? So when we have reached to the end, then we can insert new node, right? Yes, it's pretty nothing. It's all about common sense, right? Another thing, many of people have understood that, okay, Anton, you are just telling me that when you are inserting a node at the beginning, then you are, what you're doing is we are making that new node's next pointer, we're copying it to the head, right? Or making it to the head pointer. But you tell me, guys, what will you do when you're inserting that exact node in the last? What will be the exact approach? Can you guys find the similarity between inserting in the beginning and inserting at the end? See, inserting at the beginning, what we are doing is we are making the new node's next pointer pointing towards the head, right? And we are pushing that head pointer to that newly starting node, right? But here we don't need to push anything because you don't have a last pointer like the head pointer we're having in the linked list. So there are basically two pointers present in the overall linked list structure that is given, that is the head pointer and the next pointer in every node. So in the last, there is a similarity that is happening between these two problem statement, that is in the when we are doing in the last one, then we need to make that newly added nodes next pointer pointing towards the null, and the previous one will be attached to the newly added. So we are doing in two operations here, we were doing two operations there. So you are similar, some things are different, but there is a pattern, right? There is a pattern matching between these two. So all about common sense, guys, nothing to worry about, nothing so complex. If I start with the coding portion, let me just delete this. I guess you have noted down this one, this is very important. If I start with this, suppose let's say it's void end, end means insert an end, okay? I give the data, yeah, and now I make a basically new node equals to new node data, right? Right? Am I okay, guys? I guess. Yeah. Now the thing point is, there's a note I'm gonna make you write. Note, simple small note. As we are inserting at the end, we need to check if the linked list is empty or not. If it is empty, like there is no node available, then we're gonna insert only the only one node, right? Because that when you're inserting an node in an empty linked list, that particular node will become the first node. I mean, the head will point towards the first, so there is no like last thing. So there will be only one node after inserting. That means that node will be the starting node and the ending node as well. So the head will point to that starting node, of course, and the next pointer will be null. So there are two cases, right? So So we're gonna check. Okay, I think we cannot write over here because of the fact something. Okay, guys. So this thing now we need to give it that check, right? If the list is empty, so we can basically do this. If head equal to null, then we can basically create a new node or insert, basically, yeah, insert with the data that's been provided. That will be only one, because the only node, how, why we are doing head equals to new node, because as usual, only list was empty. We are inserting a node that will be the only the starting and the last node, so the head will point towards the starting node as by the rule. So we are doing the head equals to new node, right? Not a problem. Next, new node. Now if this is not true, then it's okay, it will just go to the rest of the statement. Okay, the control flows down, not a problem. New node equal to, we can do null, right? Sorry, next. Why we are doing this? Because as I told you, that the last node's next pointer will always points to the null. So easy concept, easy, nothing to be more complications or nothing to get into more complex. So next, I'm gonna create a pointer. Let's say the last pointer, because this pointer is gonna traverse through the list. Okay, this is that person I was talking about, that hey, you go and find the last of the node and you insert this node there. So that person is this, the pointer. Okay, the initial value, as okay, you might be thinking why this node last equals to head, how it is happening, and that this or that. So I'm gonna tell you that, just a minute. And the initial value of that last pointer will start, because it will start from the head, or it will start from the 1th index or first node. So it's head, right? Because the head is not moving, right? The pointer that we need to traverse, the pointer with the pointer, we should traverse with a person in it, otherwise it's not gonna happen. Traversing to a linked list is just traversing with a pointer, right? The head will not move. Okay, or basically we are creating another person. We are making this person's or variables, or you can say pointers, initial value to the head. That means that pointer starts from the beginning of the node, it traverses till the last, and checks while last dot next equal to null. That means we have reached, right? Sorry, not we have not reached. So until unless we have not reached, this will be last equals to last dot next. This is how we basically traverse. Last equals to last dot next means every time the last pointer getting updated with the next node's pointer. Okay, so like this is how we go from one th node to two-th node to third node to fourth node. This is how we traverse through the linked list. Okay, so that this is nothing. Till then we do this, and if we basically don't find, if we basically, when we reach it, we, this thing is done to basically do what, to basically fast forward and reach the last node. This while statement has been inputted into the whole functionality just to fast forward, because the control cannot skip the last the control cannot skip the while portion, right? So it will go to the while loop. If the last pointer is pointing towards the second node or the third node, it will still match the condition because it's not the last node, and it will just traverse, like it will just skip the first node and second node, and it will go to the last node. This thing, this while loop portion, is being used to skip till the last pointer reaches to the last node. So when it reaches, then its last dot next will be equal to null, because it's the last node, and the node's last node's next pointer always points towards the null. We know that, we have done it 10 to 20 times. We have known it by theory. We have known it when we were kids back in the school days, or the theoretical portions. These are the basic fundamentals of linked list, right? So if not, if we have reached to the last node, then what we can say is that last dot next, I will connect it with a new node. Like on the previous one, if you can go back to the video, you can see how we have done that. New node dot next equals to head, because we are inserting before that previous the previous starting node, we are inserting in the front. Someone comes, if someone, you're standing in a line, someone comes and stands in front of you, right? That means what? He's standing in front of you, so they are doing, he's standing before you, right? So not after you, it's before. So when we are doing before, then that time that will be new node dot next equals to head, and when you are doing after, that will be last dot next equals to new node. So there is the difference. If you want to, if you don't understand, if you're getting little bit of confused about this, you can also think in this way, like this node is, you have two nodes initially, and first I'm going to insert another node here. So this goes like, the arrow goes like this, then another insert here, then this, right? So the arrow goes like this, first this one, then this one, then this one. So if you want to insert in front, then this portion, then this one. So new node dot next equals to head, this head. Initially the head was here, then we used to push it to here. So leave that. First the head was in the initial previous node, new node came in, new node dot next equals to the head. We did that, right? We did that. But here there is no head pointer, we have the last pointer, we have created it, we traverse it. Now this will happen, the last is here, as we traverse till the last node through this while loop. The last dot next points to the next new node. So this is all the concept. This is very easy concept, nothing to memorize, nothing to mug up. It's all about the concept. If you are inserting before, then the first nodes will be first, that new node dot next equals to head. If you are inserting after, by concept, by common sense, everybody knows this, the last pointers, the last nodes dot next equals to the new node, right? Because the last pointer is pointing towards the last node. We have traversed, we have skipped all the nodes in between, and we have come using the while loop. Well, great thanks to the while loop, because it has helped us a lot. It has helped us to skip all the between nodes, and you reach the last node. You have reached the last node. The last node's that next pointer will point to the next new node's pointer, making that new node as the last. How we are doing it? We are making the new nodes next equal to null in this statement above. So first we are taking the new node, we are creating the new node, you're making the new nodes next point towards the null. So everybody knows, oh my god, that new node's next pointing towards null, that means that should be inserted at the last. If you insert that in the beginning, there will be an error that will violate the rules of linked list. So it will get inserted at the last. Compiler knows it, everybody knows it, person knows it, everything done, that will be inserted at last. Okay, previous node next pointer have to be connected with the new node. So we are doing a connection here. This connection means there becomes an arrow, there forms an arrow, and at the last the new node gets inserted, formed a new linked list having one node extra. So isn't it easy? Isn't it easy? I guess I have made you understand. Yes, no problem. Give it a thumb. Yes. No, I'm not gonna do this. Okay, give it a thumb. Can I just scroll this down? Okay. Oh yeah. So now let us concentrate on the coding part. I made you understand with a pseudocode, right? This was not a pseudocode, basically this was total coding portion, but I just did write only the functional part. But let us now write the full code with explanation again. I guess you have understood. This was easy. Not to indulge any complex or in any complication. No complex matter is being used here. Just easy. You're using a new pointer. How to traverse through linked list? We need a new person. That means we need a new pointer, because without the person we cannot traverse. Like if you are in new in some city or something, you need a tourist guide, right? Otherwise you won't be basically know where the things are, know where the sightseeings are, or many historical places are. You need to enjoy that place, right? You have given the money to the somewhere. If you are going with some tourist guide, or if you're going with some other, or if you're going so with individually, then you're spending the money for enjoyment, right? So you need to have the tourist guide. If you don't know the city or the country you're visiting, it can be the Paris, France, or somewhere. Oh, sorry for me, Paris is in France. Not the matter. Pardon me, my bad. But if you're basically going Paris or Lisbon, somewhere Brazil or somewhere else, you definitely need a tourist guide. Otherwise, it will be a problem for you, because Google Maps not gonna give you that efficient thing that a person can give. Okay, no offense to Google. Okay, I'm not gonna because if I do something, that will be a copyright for my video. Okay, no offense. Okay, Google Maps is very good. It's fantastic app, because nowadays people people's lives are happening very easier. It is it is going smoothly because of Google Maps, because you see in Uber and Ola, everybody is using Google Maps, because nobody everybody doesn't know the roads and the places that you live, but they are following the Google Maps, the location, live location, and they're coming to your destination, picking you up, and then they're dropping you at your desired location. So Google Maps has been very good these days. Nowadays, so many updates there are coming, and the developers are giving so many updates in Google Maps application. So it's good. I'm not comparing with that, but I'm just telling you in a common sense that for some people it is easier to have a person as a tourist guide rather than an internet or any other application. So keep that in mind. keep it just keep it in a very friendly way. I'm not offensing anything. Of course, technology has been very vast these days, and it is making our lives better and better, and me me being the developer understands that how what is the importance of technology nowadays. So coming to the main point, I guess you have understood these things. It's very easy, nothing to mug up, nothing to memorize. Let's jump in the code right now. Okay, so let me hop into Google Chrome, and let me okay, this compiler is very good. If you want to use an online compiler, you can check out the programmers.com. You have this Python, C++, Java, C Sharp, JavaScript, and SQL, and also HTML, CSS. Okay, you can just do it, because sometimes people don't want to use the heavy applications or heavy compiler in the machine, so they just want to do it on an easier aspect. So you can check this out. A really great compiler. Okay, so let us now jump into the code. Let me just tell. Okay, linked list insertion big. I guess I'm writing this right spelling, right, guys? And, am I writing the right spelling of beginning? Yeah, I'm writing it. Okay, okay. Let's start. Okay, here many of you, I guess, you don't know how to write class or objects, or you might be not knowing what is Java, how to write syntax. You might be practicing your codes with C or C++. So to them, For them, basically, I'll recommend, not this video is not for you guys, but you can still see it. You can see, if you want to see the logic, if you want to learn how the logic is happening. I've been teaching you for minutes, so you can go and check that out. Please don't skip this video. This is very informative, and if you skip any part, you won't be understanding the next part that I'm teaching. Okay, so for absolute beginners, this video is not for you. I promise for you guys, I'll be bringing the full Java course and object oriented programming language, uh, pillars and all. Okay, so not for you. I can make a head pointer. Let's keep it a global, right? Because it will be easier for us. I create another class, let's say node, yeah, and here I give another next pointer as equals to null. Okay, not here. I'm gonna create a constructor and then I'm gonna initialize it, right? So data and then node. Then we pass this with the data, and now what we can do is we can basically okay changes this to d. Okay, otherwise if you use the same thing as the global parameter and the parameter in the okay global variable and the parameter that is been passed by the constructor, then you should be using this, okay, this keyword, because this keyword refer to the variable that has been associated with the class, not with the functions. Okay, so what if you guys don't know what is this superclass and all those things, wrap class, I'll be mentioning all these concepts in the Java course, so don't worry about that now. Okay, and I keep this in null. Now it's over. Now I can basically create a insert add bed, right, and I can give the data portion, create a new same. I'm not doing anything new. Same, as I said you, this will be as the new node is being inserted before the previous one, so first the new then the previous, so equal to head, and the head pointer now will point to the new node, pushing towards every starting new node. Okay, so done. This line of code is just for the beginning. Okay, so I guess it's done. Yeah, now we can move towards the end portion also. Insert at end, right, and data. As usual, I'm gonna make a new node equals to new node data, and I'm gonna check if the list is empty. If it's empty, then I'm gonna create only one node, and that's it, right? I'm gonna return from the function, yes. Otherwise, I'm gonna first do a node, create a last pointer, initialize it with the head, and I'm gonna make the new node's last equals to null, because it is being, as by the rules, it is going to be inserted at the end, and we know by the rules that every end node's last pointer points towards the null. So yeah, so we have created the node and we have designed it by the rules. Now our work is to insert it. Okay, next step will be skip all the middle nodes and reach to the last. How we can do that? By traversing, yes, last dot next not equals to null. If that's true, then last equals to last dot next. Skip all the middle nodes. Once you have skipped, When it reaches to the last, it will not enter to the while condition, go to the control flows to the next statement. Next statement is last dot next is equal to the new node, and wait, am I doing right? Yes. And that will return from function has successfully inserted the end. Now let us make a void main public static void main. The people gonna say that if this is not static, what's gonna happen? We also can write basically public void static. Okay, so that's not a problem. String args, right? Now we can make an object, right, from that class. Linked list l is equals to new linked list l dot push. Let's us first push at the beginning with 10. L dot push 20, right? 20 10. Okay, this is gonna be like 20. Okay, 20 10 30. 30 will be okay, not okay. I'm just writing my bad. Insert add beg and insert add beg, right? Insert at end, let's say 30. Now the point is we haven't made the function to display the list, so let's do that. Nothing, it's easy. Let's say print, and we create another same guys. You can basically create, let's create a pointer. Let's say traverse equals to head, initialize with this one, then while traverse not equals to null, this means that the no linked list is not empty basically. Okay, this while condition is it will just run till, not till, if the linked list is empty, that will not the while statement won't run. If it's not empty, then it will. So traverse not equals to null. If basically you use your common sense, if the list is empty, what will it print? So yeah, that's a loop. Now we will do just system.sopln or sysout. Sysout with what? System.out.println traverse dot data. Okay, this is how we print the data portion. We use dot data reference. Okay, that is the reference variable. That is we are referencing to the data of the node. We're catching it. Okay, the dot signifies the reference, nothing else. And we can basically create this, yeah. And we need to traverse, right? So how can we traverse to the next? Traverse equals to traverse or next. We are each time we are updating the pointer with the next node's pointer. Okay, we are updating or we are pushing from 1 to 2 to 3 to 4. This is how we do it. We don't do y plus plus or traverse plus plus. We don't do like that. We do it this way. We are updating the value to the next node. Okay, so that's done. Let's now see how it's looking. Something gonna give me error because I think this can give error. I mean, let's see. Okay, it is taking so much time. Let me just copy this and refresh the page, right? And you paste it. Now I run this. Let's see. Okay, I don't know, guys, why it is taking so much of time, but uh, we can also do the things. Basically, let me just try something. Okay, let's try something. Oh, man, okay, this thing. Ah, okay, let me try it. Another page. We can copy this and I can go for online. Yes. Let me try it. Yeah. Yes. Okay. Now let's say 10 and insert at big. Let's say 20 and L dot insert end. Let's say 30, right? And at the last, let's print the list. Okay, let's see. Mm. Okay, weird problem is that if you ever use it with any other class like linked list or something, it takes time, right? I don't know what problem is here, but I guess they're gonna fix it most probably. I guess. Okay, so new node or last equal to null. You don't find it. Okay, sorry. We need to do this. Yes. What the hell? Some mistake is happening. Let me see. Oh, sorry, man. The next pointer. Sorry, my bad. Okay, so as we can see, uh, let me. This is so pathetic. Let me just make it a little more beautiful. Okay. Yeah. So as we see, 20, 10, 30. 20 is being inserted at the beginning. First we insert 10, then we insert 20 at the beginning, then we insert a 30 at the end. So it's done, and this is pointing towards null. So basic thing is, if you see while the code, while this thing, even with this statement, okay, as we are giving this statement in the while loop, you can idealize, we can you can basically analyze one thing, that from here also you understand that if in the last node this is pointing towards null, because it is not pointing to any of the thing right over here, so it is pointing towards null. So you can understand by that also. So there are so many of aspect you can make yourself understand. So data structure has this beauty. So nevertheless, I guess you guys have understood how to print, how to insert at the beginning, insert at the end. And the last portion that I want to share with you is to check and count the number of nodes that are present in the list, or the length of the list. Okay, so let us do that too. I can create an integer function called find length, and I can create same traverse pointer. I can initialize with it. I guess this thing now guys, you have understood. As you have understood this function, if I ask you guys to do that yourself in your home, you can do it very easily, because you have understood the concept. Nothing is there, it's just easy. So what we gotta do, same as usual, same as this one. Here we are printing the data. Here I'm gonna do what, I'm gonna initialize a counter variable, and I'm gonna print that counter. But first we're gonna increment that counter every time it reaches to the second node. Every time it reaches to the second node, third node, fourth node, whatever it is, every time it jumps to the new node, the counter will increase by 1. And at the end of the list when the while loop will understand, like traverse dot next not equals to null, somewhat like this. Then what is gonna happen? Let's say, okay, not this one, sorry, it will reach to the end, sorry. Let's say C++ and S traverse, we're gonna jump to the next node for that. Traverse dot next, yes, and return the integer C. Simple, easy. Now from here I can go to find length, right? So let's do that. Okay, yeah, you have to wrap up with a sys out, otherwise it's not gonna show me any output. Easy. That's it. So it is just a bit weird. I can add another sys out here. Just in the front element. Basically, I can add what? Next line. Seems like my bad. This. Yeah. I've been thinking the whole time, as I've been doing JavaScript lately so much, that I'm gonna do an NBSP $NBSP, and that will just give you a new space, and if I give a tag BR, it will just give a new line. So pardon me for that, pardon me. That's it. So this is the space is because of this one. Never mind. This is the list and this is the length of the list. So I guess you guys have understood. If you do, please don't forget to hit the like button and subscribe button if you haven't done already. I'll be posting some future videos of how to insert at the given position or after a given node, and then we'll go for the deletion portion. Okay, and then we'll do some lead code problems like rotate a list or find the nth node that I've already have done, or find the middle position of the linked list. All these types of problems are there, so we'll be doing that, and I'll make you understand how the logic goes on. I guess I've been trying to make you understand with a very simple concept. I guess you have understood, and if you do, please don't forget to hit the like button and subscribe and hit the bell icon for more upcoming videos on data structures and programming fundamentals. And if you have any doubt, never hesitate to basically comment down below. I'll try to reach you out there for solving your doubts. Okay, so till then guys, keep coding, grind data structures, and that's it. This is a beauty. That's it. Okay, so bye bye.